Hello, my name is Robert Bücher. I'm here to demonstrate you an application with tool tracking. You can see here a mock-up of a battery module for cars. The silver plates are representing the battery cells, while the orange parts represent the connectors. The task is to distinguish between the screw positions, which are very close. For this demo, we have integrated two solutions, and this is our well-known VERPOSE system and an active target of D-Track. The reason for having this application is this assembly is a very critical assembly. High voltage, a high security, and therefore documentation is necessary. In our standard procedures, we have a software that was trained based on the image of our VERPOSE system. So you can see here the recognition of a position which was trained before in a simple procedure. When you go to the next position, you can see how easy the system can distinguish between those two positions. In many applications, we have patterns that are recurring, so-called repetitive patterns. Here in this application, we have a typical repetitive pattern. You can see here a pattern that occurs 2 times again. How can we distinguish between those two positions? Position of here, number 1, or position of here, which is number 17. For this application, they look the same. So we combined, based on our active target, a D-Track combination. D-Track uses a target, which is an LED-based positioning, and due to the shape of the positioning, we can distinguish the tool. And our smart track system is then surveying this area and returning the 6 DOF positions to you. 6 DOF stands for X, Y, and Z, and the 3 angles. So you have an accurate position information, and this you can see on the right screen. So when I touch the position 1 again, we have the detection here, and we have here a detection of position 1. I did the 17 before. You see here the 17, and both together match each position accurately. This application on the left side is a demo which is based upon our D-Track system. Here, as I said, the software has learned based on image, pre-trained image, and on that application, the geometry of the part and its positioning information was also used. Our task is to combine those two systems so we can cover a lot more applications. For example, flat applications like these can be easily surveyed by these systems. Other applications cannot be used here. On the other hand, the combination gives our customer the ability to cover most of his screw applications, and he can decide case by case what to use. Now is the question, why do we have this combined solution? First of all, we have different situations on customer sites, and we want to give the customer a free choice which solution is the most useful one. And then we can make a license for one of these. So you take a camera, or you take a target, or you combine them. At the end of the day, we will have a cableless solution where the target and a computer with a camera is integrated. So let us discuss about the possibilities and the options in your cases. For example, what is your case? Do we cover it with such a kind of solution?